Greetings everyone, welcome to the Ship of Mystery. Today we dive into one of the deepest puzzles, time. We feel it, we measure it, it rules us. Every second that passes doesn't come back. Let's imagine time as a big river. We are all boats carried by its current, unable to stop or go back. Our experience is to move forward, watching the past fade into the fog of memory. But is this the only way to understand time? Philosophers and scientists have sensed that there might be something more, a structure hidden from our senses. What if time wasn't just a simple line, but a vast ocean with unimaginable depths and expanses? 20th century science, with Einstein, taught us that time is relative, that it can stretch and shrink. An astronaut traveling at high speed experiences time differently than we do on Earth. This discovery opened a crack in our understanding. If time is flexible, what other unknown properties could it have? Could it have more dimensions than we experience? Tonight, we'll explore that possibility and ask ourselves, what is time really? Are we ready to leave the known shore behind and enter the mystery? We live in a world with 3 space dimensions: forward, backward, left, right, up, down. But time, we've always treated it as just one dimension, only moving forward. What if time also had 3 dimensions? Imagine it's not a line, but a volume. We could move not just to the past or future, but also sideways and up or down in time. Time travel would no longer be just going back or forth. It would be exploring a whole time landscape with alternate realities. Some theoretical physicists suggest that, at the most basic levels of the universe, there might be extra time dimensions, all packed up and invisible to us. Our experience of time as a single line might just be a shadow of a much bigger structure. Think of a creature that can only move back and forth on a wire, not knowing there's a 3-dimensional space all around it. What if we are that creature stuck on a single timeline? The idea of 3-dimensional time turns us into potential explorers of a universe full of realities. Could we learn to sail that huge time ocean? What would we find if we could move in all directions of time? The mystery is just beginning. We all travel into the future, second by second, and we can't stop it. It's like being in a boat pulled by the river's current. We don't need to do anything, it just happens. Einstein's theory of relativity tells us that this journey can speed up. At speeds close to light, time slows down. GPS satellites adjust their clocks because of this effect. It's a proven fact. So, traveling to the future isn't just possible. It's part of how space and time are built. In a 3-dimensional time, this forward movement would be like walking in a straight line along one of the time dimensions, T1. Even if we run faster, we're still on the same path, unable to explore the side roads. We're stuck in a single line of events. The real excitement begins when we ask ourselves, can we get off this main road? What lies beyond the known current? Traveling to the past is like trying to row against the current of the river of time. Physics puts up walls like cause and effect. The grandfather paradox reminds us of the dangers of changing the past. But Einstein's equations allow, in theory, for loops in space-time, though they need really extreme conditions. In a 3-dimensional time, going backward would be like walking the wrong way on the T1 axis. But would we change our past or create a new timeline? Maybe when we travel to the past, we don't go back to our own past, but to a different version, in another time spot. This way the cause and effect of our first universe would stay safe. Traveling to the past becomes about making new worlds, not changing our own. The mystery gets deeper. How many paths could there be? Traveling sideways in time would let us explore other realities, the what-if worlds. Every choice, every event, could create a new branch on the tree of time. A 3-dimensional time would be the map to navigate this multiverse of possibilities. We wouldn't just go to the past or future, but to other presents, born from different pasts. It would be like turning a corner and finding a parallel version of your own street. We could visit worlds where dinosaurs didn't die out, or where history took other paths. Science fiction calls it a multiverse. Quantum mechanics suggests it in the many worlds interpretation. If it's true, these worlds really exist. 3-dimensional time would be the vehicle to travel between them. Are we ready to explore the endless library of reality? Stephen Hawking was fascinated by time travel, even though he was doubtful about traveling to the past. He suggested the chronology protection conjecture, that the laws of physics would stop travel to the past to keep the universe consistent. He threw a party for time travelers and sent the invitations later. Nobody showed up. Michio Kaku, on the other hand, is more hopeful. He talks about wormholes as possible shortcuts in space-time. A wormhole could connect not just places, but also different moments in time. For Kaku, traveling to the past could mean jumping to a parallel universe, which would avoid problems. Science doesn't know yet if this is possible, but it doesn't rule it out. The smartest minds tell us it's hard but not impossible. The discussion is still open. Science tells the difference between what's possible and what's just imagined. Traveling to the future is a proven fact. Time dilation is real. Traveling to the past or sideways in time, though, are just ideas for now. We don't have any proof from experiments. Science fiction explores these ideas freely, inspiring many scientists. What's fantasy today could be real tomorrow. Things like going to the moon or talking to people instantly seemed impossible 100 years ago. The line between science and fiction is always changing. While science moves carefully, fiction sparks our curiosity. Maybe we just need a new big idea to explore the three-dimensional ocean of time. What amazing things will we discover? The future is wide open. Time travel would bring up tough ethical questions and tricky problems. The grandfather paradox and the information paradox warn us about the logical dangers. Maybe the universe fixes itself, stopping big changes in the past. Or maybe when we travel, we jump to another universe, leaving ours untouched. Beyond logic, moral questions come up. Should we change history if we could? A small change could have unexpected and terrible results. The power to travel through time would be the biggest and most dangerous thing ever found. Maybe that's why we haven't seen tourists from the future. Either they're smart and don't use it, or they mess up trying. The risk might be bigger than the reward. We've explored the idea of three-dimensional time, a space we could learn to navigate. Traveling to the future is science, the past and parallel worlds, a mystery. Every discovery brings us closer to understanding the true nature of time. Perhaps there are hidden temporal dimensions waiting to be discovered. If you had the key to navigate this temporal ocean, what would you do? Would you travel to the future, the past, or explore alternative lives? The answer isn't just in physics, but in who we are and what we long for. If you could choose your reality, which one would it be? Good night, and until the next mystery ship.
What if everything we thought we knew about time is wrong? What if the very fabric of reality is more complex than we've ever imagined, more than just a straight line? Today, we're exploring a groundbreaking idea that time itself might have three dimensions. And believe it or not, this could completely reshape our understanding of the universe and unlock some of its deepest secrets.
Normally, we think of space as three-dimensional, length, width, height, and time as a single arrow moving forward. But what if at the fundamental level, time isn't just one thing? What if it's multidimensional, just like space? And if that's true, it might explain some of the strangest phenomena in quantum physics.
Our current framework, Einstein's special relativity, unifies space and time into a four-dimensional space-time and tells us nothing can surpass the speed of light. But what if that's only part of the story? What if, in some hidden corners of the universe, the rules change, where moving faster than light becomes not just possible, but natural? Could that help us understand why particles sometimes behave in ways that defy all logic? Take quantum mechanics. Particles acting like waves, existing in multiple places simultaneously, entangled across vast distances in ways that seem instantaneous. It's like the universe has a secret language that defies our everyday experience. But what if those bizarre behaviors are just clues pointing to a universe with more dimensions of time?
Now, here's where things get truly wild. Imagine a universe where some entities already move faster than light, faster than anything we can imagine. According to the newest theories, if you could perceive or navigate these higher dimensional time realms, the universe would look completely different than what we see now. Instead of three spatial dimensions, you'd perceive three dimensions of time and only one of space. From this vantage point, particles wouldn't be tiny billiard balls zipping around. They'd act more like waves, spreading across multiple directions, overlapping, interfering. Think of ripples in a pond. When a stone hits, the waves radiate outward, crossing paths and creating complex patterns. That's exactly what quantum phenomena look like when you change your perspective.
Seeing beyond our familiar space and time could unlock the mysteries behind entanglement, superposition, and wave particle duality. It's as if the universe is a vast, interconnected web where particles are merely ripples in an immense, multi-dimensional ocean. In fact, many modern theories, like string theory or those about the early universe, already involve fields that extend faster than light. These fields ripple across all of space and time, connecting everything in ways we're only beginning to understand. Could the mysterious particles known as tachions actually exist? And if so, what would they mean for cause and effect, our foundational understanding of reality? If tachyons are real, they would shatter our concept of cause preceding effect. Imagine sending signals faster than light, creating a universe where cause and consequence are tangled or even inverted. It sounds like science fiction. But quantum physics already bends these notions. Perhaps our universe isn't constrained by the simple rules we've assumed. Maybe it runs on a far stranger set of laws.
So, what does all this mean? That reality could be far more mysterious and far more interconnected than we've ever believed. Instead of being isolated points, particles might be waves, fluctuations spread out across a web of multiple higher dimensional timelines, constantly interacting in ways we're only beginning to comprehend. And if these ideas hold true, the implications are staggering. Faster than light travel, time manipulation, even access to parallel futures, these might not be just science fiction. They could be rooted in the deeper, multidimensional fabric of reality itself. Imagine stepping between different timelines or alternate versions of history, not through portals or sci-fi gadgets, but simply by understanding the true nature of the universe's structure.
This could be the frontier where physics, philosophy, and imagination collide. If the universe is woven with multiple higher dimensions of time, then quantum entanglement, particles behaving in bizarre ways, and the very flow of causality are part of a grander cosmic puzzle, one that might someday be unraveled. So, next time you think about time as a simple arrow, remember, what we see as a straight line might just be one slice of a complex, multi-layered universe. Could understanding this hidden multidimensional time be the key to exploring faster-than-light travel or even discovering the ultimate theory of everything? The universe may be far stranger, more intricate and interconnected than we ever dared imagine. And perhaps in the depths of these hidden dimensions lie the secrets to unlocking our most profound cosmic mysteries.
Are we ready to rethink reality? Because the answers might be lurking just beyond the limits of our perception, hidden in those extra dimensions of time, waiting to be discovered. The more we explore these ideas, the more we realize that the universe might be far more interconnected and mysterious than our everyday experience suggests. Imagine a reality where the boundaries between past, present, and future blur, where different timelines coexist and influence each other in ways we've only begun to understand. If these higher dimensions of time exist, they could hold the key to unlocking unprecedented technologies like instantaneous communication across vast distances or even traveling through time itself.
The implications are staggering. If we can understand and access these extra dimensions, conventional notions of causality, cause and effect, might need to be rewritten. We could be on the brink of a scientific revolution, one where the mysteries that have confounded physicists for centuries suddenly make sense. Think about it. What if teleportation, time travel, or communication across different timelines are just problems waiting for the right perspective, waiting in the hidden depths of multidimensional time? It's an exciting, mind-expanding frontier. And while these ideas challenge our basic understanding of reality, they also inspire a profound sense of wonder. Because at the core of it all, the universe might be a complex, beautiful tapestry woven with layers of time and space beyond our current comprehension. So, the next time you ponder the nature of time, remember, we're just scratching the surface. There could be vast realms of existence lurking just beyond our perception, waiting to reshape everything we thought we knew about reality. And perhaps, understanding those hidden dimensions will be the ultimate journey, one that takes us closer to the truth of the cosmos itself.
Are you ready to explore the unseen depths of reality? Because the universe's greatest secrets might be just beyond the horizon of our understanding, patiently waiting for us to uncover them.
If you enjoyed this video, give it a like, share it with your friends, and subscribe so you don't miss out on future ideas that challenge us to think outside the box. We'd love to hear your thoughts in the comments below. Until next time, and don't forget to always maintain that curiosity that drives progress. Also, explore even more fascinating content on our channel. From life-changing tips and cutting-edge technology, to the mysteries of spirituality, travel to various countries, delicious recipes, health hacks, and language learning, there's something here to spark your curiosity and elevate your life. Dive in and discover a world of knowledge awaits us.